Calculate the curved surface area and the total surface area of the cone shown. Give your answer in terms of pi, so pi needs to be in your answer. Okay, so here's our cone. We do not know what the radius is, but we know that the perpendicular height is 16 and the slant height is 20. So to find the surface area of the cone, we must know the slant height and the radius. So we know the slant height, but we need to figure out what the radius is. So we actually have a right angle triangle inside of our cone, formed by the radius, the perpendicular height, and the slant height. So we can use Pythagoras Theorem to figure out this unknown side, which happens to be the radius. So Pythagoras Theorem is a formula that can only be used on right angle triangles, and we know that this is a right angle triangle from this symbol here. But we would have known anyway, because we have a perpendicular height and we have a base, and they meet at a T-junction. So even if this was not drawn in, we would know that there is a right angle triangle contained inside every cone. So that's our right angle there. So this would be our hypotenuse, and this would be our other two sides, so our adjacent and our opposite. So Pythagoras' theorem, given to us in the formula book, is c squared equals a squared plus b squared, where the c squared represents the longest side. So in our right angle triangle, the longest side is 20. So the longest side is always across from the right angle. So our c is going to be 20. So it's going to be 20 squared equals r squared plus 16 squared. It doesn't matter which one of these gets labelled as the a or the b, because we're going to add them together anyway, so we'll get the same answer. So step 1, we're trying to figure out the radius. So the formula used here is L squared equals h squared plus r squared, which is the exact same thing as Pythagoras' theorem that we have down here. But they're labelling the hypotenuse, or the longest side, as L, representing the slant length. The h is the perpendicular height, and the r is the radius. So it's just different letters, but it's the exact same formula. But since this is the formula that would be given in our formula tables, I'm going to work from this formula. So the c is the longest side, which is 20. So the c is 20, and I'm going to have c squared, which is 20 squared. And 20 squared is 400. Then the a is going to be the 16. So I'm going to have 16 squared, so a squared is going to be 16 squared, and 16 squared is 256. And then the b is going to be the r. So we're going to have b squared, which we'll just call r squared. So we have plus r squared, and that stays the same. So c squared equals a squared plus b squared, 20 squared equals 16 squared plus r squared. So the 20 was the c, which is the longest side, that's the most important thing. And then we had 16 squared plus r squared, so a squared plus b squared. So 20 squared is 400, 16 squared is 256. So 400 equals 256 plus r squared, and we want to solve for r. So we bring the 256 over the equal sign and becomes minus 256. 400 minus 256 is 144, and that's equal to r squared. So r will be equal to the square root of 144. And the square root of 144 is 12. So the radius is 12. Okay, so that was step 1, find the radius. So remember, we want to find the curved surface area and the total surface area. But we needed to find the radius in order to do this. So the curved surface area means the area of the curved part of our cone. So basically, just not the circular base at the bottom. So the curved surface area is the area of every other part of the cone, so the curved part of the cone, just not the circular base at the end. And the formula for curved surface area, CSA, is given to us in the formula book as pi r L. So the r represents the radius, and the L represents the slant height. so this 20. So the L in our formula pi or L is 20. And we now know that the radius is 12. So we substitute into our formula for the curved surface area, pi or L. The pi or and L are all stuck together, which means we multiply. Pi multiplied by 12 multiplied by 20. So the radius is 12, the slant height or the slant length is 20. So pi by 12 by 20. 12 by 20 is 240, and we just stick on the pi because we were told we want our answer in terms of pi. So we don't press SD on the calculator and get a decimal. We leave it as 240 pi. So that's the curved surface area. Now we're also asked to get the total surface area, which means we get the curved surface area, which we already have, and we add on the area of the circular base. So we've already got the curved surface area, 240 pi units squared, and we just get the area of the circular base and we add it on. So the total surface area equals the curved surface area plus the circular base. So the formula for the area of a circle, pi r squared, all we have to do is swap the r for the radius, which is 12. So we get pi times 12 squared. 12 squared is 144, and remember we would just stick the pi on because we want it in terms of pi. So we get 144 pi. The curved surface area we found already over here to be 240 pi. So we get 240 pi plus 144 pi gives us 384 pi units. So the curved surface area ends up being 240 pi units, and the total surface area ends up being 384 pi units squared. So the most important part of this question is to realise that whenever we're dealing with cones, there's a right angle triangle inside the cone, and we usually need to use Pythagoras Theorem in order to figure out what the radius is. And sometimes we might be given the radius and we need to use Pythagoras Theorem to figure out what the perpendicular height is. Or we might be given the radius and the perpendicular height and we need to figure out what the slant length is or the slant height is. So just be careful whenever cones are being used. Usually Pythagoras Theorem is being used also.